All right, this is 510. I'm going to keep going. I'm going to see how far I can go. I'm at home tonight. Um, I just feel motivated. I'm going to go through some of this so that way utilize this time. I'm not sure how much I'll actually get through, but we'll see, right? This is 510. Not much going on here. You can watch the video if you want. Down at the bottom, it has a summary. It says, while programs are typically designed to achieve a specific purpose, they may have unintended consequences. I teach an intro to computer science class, and we have a project on a moral machine project done by MIT, and it talks about self-driving vehicles and how sometimes there's bias that goes into how these self-driving vehicles work. Some of the AI that goes into it, sensing different things, and they give you a few scenarios, and you have to choose whether or not which one you feel like is, I guess it's like an ethical question. But with that though, there are sometimes unintended consequences. I'm not sure why they put 510 in here. It seems like they kind of just threw it in here because they didn't have anywhere else to put it. And just threw it at the end of, I don't see a reason why it has to be in chapter 5. But they just kind of threw this in there. It says system reliability is limited. Programmers should make an effort to maximize system reliability. Legal issues and intellectual property concerns arise when creating programs. 100%. You see all the time these big tech companies are in and out of court due to something that they did, privacy issues to just intellectual claims all the time. People creating different technologies, and some of these bigger companies especially are just blasted nonstop with legal concerns. Some companies operate in the gray area just because laws and technology are not able to keep up with how fast technology is moving, which is scary. But at the same time, the bureaucracies that are in place in order to make things happen are not moving as fast as the increases in technology. So some things that are legal today might not be legal tomorrow. And just over time, you'll see that some of these businesses are created because of the gray area and work in the gray area. But then when things become illegal, my students even ask me, they're like, are you capable of doing A, B, C? I say, I would not do something that is illegal or unethical. I want to make sure that with that too, though, what is ethical? Right? What does that mean? So our society is constantly changing. And whenever you're creating any sort of software, creating a program, you have to take into these concerns. And usually that's why there's different layers to this where, approval, that is, where if you create something, it's good to ask other people before just, creating something and posting it. Have different mentors or different people in your life be able to look over what you're doing and think of potential concerns with that, to play devil's advocate. It says, the creation of programs has impacts on society, economies, and culture. 100%. These impacts can be beneficial and or harmful. So, like I said, finding the right balance is important. That's pretty much it here in 510. It says, choose a software application that has social and ethical implications. Discuss the beneficial and harmful effects of the software application. You can pick anything, right? That's pretty open-ended. It just says, discuss it, prepare a presentation for your class. I'm not sure what everyone's classes require. Mine's not going to require for that because there's so much to cover here in chapter 5, but that's 510, social impacts of CS. Then there's 511, which is the Unit 5 summary. goes through the things we talked about in this chapter. What a class was. We introduced classes in Unit 2 when we went through the turtle class, but now we went a little bit further in depth. We talked about what makes up a class, whether the instance variables or the constructors, different methods you're able to write, the toString method. So a lot of cool stuff they're able to learn in this. And I purposely like taking chapter 5 a little bit slower just because there's so many new concepts and things that we didn't cover in AP Computer Science Principles. And also things that, like, this is a foundation that we're building a lot on top of here in the future. If you don't understand this stuff, I recommend going back through it, taking extra time to go through these practice problems here at the end, which we're about to dive into. So, class, compiler, different errors, the constructor. I'm not going to read through the definitions because if you have questions on this, go back and watch my other chapter 5 videos, or just refer back to whatever it is you did before. Different keywords. We also talked about static in here as well. Not sure why that's not included, but different keywords we talked about. Okay, 5.11.3, vocab practice. It says, drag the definition from the left and drop it on the right. Does the actual work in an object-oriented program? Translates a Java source file, ends in .java into a class. I'm going to drag that into compiler. A programming language that you can use to tell a computer what to do, Java. Defines a type and does the actual work in an object-oriented program. Defines a type. Interesting. That's not the best definition, I guess. I'm going to say, let's try this. Oh, wants me to switch these up. That's just a weird question. An object defines a type. Did I just put them right back in the same spot? Yep. Interesting. So it says object does the actual work in an object-oriented program. Okay. A class defines a type. That's a very vague definition. Interesting. Okay. I was thinking because we're creating instances that would be a similar definition. That's a bit confusing. Let's see. I guess if I would have just read this up here, right? Objects do the actual work in an object-oriented program. Okay, so you're creating objects from the class, so that's why they put that in there. Class defines a type. Use to define a new class. I don't know if I would use type there. Drag the definition from left to right and drop it on the correct concept on the right. Click the check me button. So defines a behavior where execution starts, initializes the fields of an object after it has been created, holds data or property. Okay. Defines behavior, that would be a method, where the execution starts, the main method, initializes the fields of an object after it has been created, and then holds data or property in a field. Let's see if that's right. I thought the last one was right and I was wrong, so there we go. Okay, constructor, method, field, main method. All right, common mistakes. Just some listed down there. Once again, this is a review, but we'll go through this. Forgetting to declare an object to call its method. Forgetting to write get set methods for private instance variables. Forgetting to write a constructor. And these others too. Okay, I'm not going to go through and read all of them. This is just a summary of everything we've went through in Unit 5. And that's 5.11, the Unit 5 summary. All right, some good stuff here. 5.12, mixed up code practice. Okay, so these are all mixed up, and we're going to write them the right way here. It says the following program segment should define a dog class with a constructor that takes one parameter and sets the value of the dog's private name attribute to that. There also should be a getName method that returns the name. Okay, let's go ahead and work through this first. Okay, I'm going to take my public class dog and looks like I'm going to go ahead and drag. I closed my method here, but then it already opened up getName. So first, starting off, I want to write my instance variable. It's going to be private. And then we're going to have a constructor. And remember, we call the constructor the same exact, make it public. And whatever the class name is, that's the name here. So it says string name, dog, and whatever's passed into dog, we're going to go ahead and use this dot name and assign that to our instance variable. Okay, then we're going to end the constructor here. And then we are going to see if we want to return public string getName here would return this name. I think that's good. Let me read back through it. So I have my dog class. I have my instance variable of name, my constructor here. Whenever my main method's ran, it passes an argument that stores a parameter called name. We're then assigning it to this name, okay, allowing us to use the same variable name there. Close the constructor, and we open up a getName, which is my getter, and that will return whatever the name is that returns this dot name. So if I check it and run it, perfect. Okay. Next up, it says the following program segment should define a dog class with a constructor that takes two parameters. Let me go ahead here and just start off. I'll say public class dog. Go ahead and close our class as well. And then I guess I want to, it says, with a constructor that takes two parameters, a name and an age. Okay, it's important that when we do this, we declare the type, right? Name is a string, age is an int. Okay, what this is going to do is going to also refer to my instance variable. So I guess that means I have to put my instance variables up here. Private string name, private int age. Those are my instance variables, my constructors here. These parameters come in. Name is assigned name, which brings to this instance variable. Age is assigned name, this age, which brings it to this instance variable right here. And that ends the constructor. 2a2b, 3a3b. I think that should be it. Okay. Closes our constructor right here, ends class. And check it. Perfect. So that's what I got. All right. Moving on. I have another one. Oh, this is the worst. We have to drag it down. Right. So I like it when it's side by side. It's a lot easier to drag left to right than dragging it down. It's a pain in the butt. All right. So a cat. So I'm going to go ahead here and just one trick that one of my students taught me was, of course, one of my students taught me, right? I got it. And rather than dragging it down, just hold the down arrow key and just tap in the down arrow key, which gets me down there. Lifesaver, right? Drag it, tap the arrow key down. Got it. Okay. What's this even doing? Okay, it says takes two parameters, name and age. Okay, so my instance variables are needed. So I'm gonna tap that down button and then put that there, string int age. This is the beginning of my constructor here. I then want to use, right, these, right, this name, this age, and my constructor, assign these to the instance variables, right? Then we want to close our constructor. But then let's read and see what we have to do. I was like jumping ahead here and then not reading and then getting it wrong. So let's look. It says these parameters should be saved in correspondingly named private attributes of cat objects. There should be a make sound method that prints meow. Finally, there should be a toString method that returns everything, name, age, etc. Okay, so we want a make sound. So let's see which one's different. Since I don't have return, this would be void. Let me go ahead and put this down here, right? And my constructor, the void, the return type is void because I'm printing something out. I'm going to then print system.out.println, drag that down there. It's going to make the sound. And then I'm going to end it. Okay, close that make sound method there. And then I'm going to, let's drag this down. This is going to be my toString inside what's in here. Let me run it, make sure I got it right first. I did. Let me explain it now. So I have my cat class. Inside of my instance variables, string name, int age. I then have my constructor. I have name that's passed in, age that's passed in. This name assigns it to the instance variable. This age assigns the instance variable here. We close the constructor, and then we created a make sound method. The reason why we made it void is because there's nothing we're returning. We're just printing something out, right? And then once we've printed meow, we close the make sound method. Then our toString method, we're returning all this stuff. Notice that public void, we didn't return anything. That's basically saying we didn't return anything. It's void. But since we're returning something here, I'm returning a string, it says public string, right? That's what the method's doing. It's returning a string. Okay, then we close it, and then we end our class. So that's what my code looks like. All right. Moving on here, the following program should define a square class with a constructor that takes one parameter. All right, so I'm going to drag my public class square. I'm also going to close it. And let's see what it wants. It takes one parameter, length, which is an integer. Okay, so I want to say, but then there's this number of squares. Let's see what that is. The square class should also have a variable number of squares that tracks how many squares have been created. Okay, usually we talked about this, like it's good to make, if we're just counting something, to make it static, right? So we're going to say public static int number of squares, and then private int length. Then I'm going to add my constructor here, public square. Okay, returns that. I'm then going to assign the parameter as it comes in to my instance variable length here, add 1 to the number of squares, and then we're going to end that constructor. Then we have a toString method, okay, and the toString will return the length, okay. Make sure public string toString. Let me run it. Let's see if I got it right. Cool. So I'm going to explain it. I have my square class. I then have these instance variables here. Once again, whenever we're declaring something static, as we had learned before, sometimes if we're just tracking the number of something, like the number of iterations as it goes through, it's good to make that static. We originally start off at 0, and then it goes up by 1 each time there. The length, as it's brought in here, is then assigned to this length. The toString gives me the length of this instance variable length. And that was right. Okay, the following program segment should define a rectangle class with a constructor that can take 0 or 2 integer parameters. Okay, so let's first go in here and create a rectangle class. I'm also going to close it. My instance variables are right here. And then I'm going to assign these as they come in. Public rectangle. Let me see here. Interesting. I'm guessing there's 2 different. So if I have, so let's read through this first. I'm just assuming this is right. This is the n, the 0 argument constructor. This is the 2 argument constructor. And then my getter. I'm going to read through this to make sure this is right. I'm just assuming here. Basically, what I'm assuming is there's a 0 argument 1 and a 2 argument 1. The 0 argument 1 initializes a length of 10, a width of 10. Yup. No arguments are passed in, or no parameters are in here, right? So I'm just assigning these to default, right? If you're just creating a rectangle, the default's 10 length and width. And then if they do pass something in, then those are assigned the length and width. And then you have a getter. The get area takes the length, multiplies it by the width. Check it. Good job. And there's the code. Okay, next one. It says the following program should define a celestial body class. The class should have 2 instance variables, orbit length and days since discovered. Okay, the orbit length variable should be initialized to the constructor, since days since discovered should be derived from orbit length and the orbit method. Okay, interesting. So my class, celestial body, need to press the down arrow again. Whoops, I grabbed the wrong one. Public class, celestial body. I'm going to go ahead and close this. And then have my instance variables at the top here. And then my constructor is over here. I'm going to drag this down. There's my constructor. And then let's see what I have here. Let's read. I always jump into this. I'm going to read all this stuff. All right, so the class should have 2 instance variables, orbit length and days since discovered. The orbit length variable should be initialized through the constructor. Okay, orbit length initialized through the constructor. Let's see what that is. While days since discovered should be derived from orbit length and the orbit method. Okay, we'll talk about that later. The orbit int num of times should add orbit length times num of times to days since discovered. Orbit length times number of times should be added to days since discovered. Okay. But the block's been mixed up. Okay. So let's see here. Days since discovered, this orbit length says the orbit length variable should be initialized through the constructor. Okay, so if that's being passed in, this dot orbit length is assigned orbit length. And then the constructor, and the question is what it's returning. In this case, what is it looking to return? So these two lines, end constructor, public void, I believe it's void because we're not returning anything. So let me go ahead here and bring this down here. Okay, public void orbit. And then what orbit's doing is it's saying that we are dragging the days since discover and we're adding these together here. Okay. Days since discovered, we're adding to that. Let's see if we got this right. Check. Oh, add more blocks. Am I 4A, 7B? Answer's too short. Does it want me to initialize this? Let's see. Let me try this one. Okay, so that's a bit confusing because I know you want to initialize days since discovered. I know you want to do that, but you can read this in one way and maybe be a little confused like I was. It says the orbit length variable should be initialized to the constructor. Okay, this is where we initialize the orbit length. It's inside the constructor. But then it says, while days since discovered should be derived from orbit length and the orbit method. Okay, so yeah, well, we got it. So it wants us to initialize this to 0 first. Okay, days since discovered. The following program, let's see, the following program should define a person class. Each person instance should have a string name and integer age. Person, let's close it. These are my instance variables here, my constructor, and that brings in name. So I'm going to go ahead and just say this name is assigned name, this age is assigned age, which puts that up into the instance variables. I'm going to end the constructor, and we'll use a get name, the getter. Let's see what this wants me to do. There should be get name and set name functions. Okay. So we'll say return this name is my getter, and assigning this name is my setter. Okay. So string new name comes in. This is how I would set this. This is my getter. Let's check it. Well done. Okay, so this is my class called person, instance variables, my constructor, which receives two parameters, name, age. So where I assign it to the instance variables. This is my get name, my getter. And when you call this method, it returns the name. Okay, but then there's also a set name method that you could use to pass in the name, which is then stored into the name and doesn't do anything. So that's why it's void. Okay. Let's see how many more of these we got. We got 3 more. All right, let's get through these 3. It says the following program should define a point class. Each point instance should have integer x and y attributes. There are associated getX and getY methods whose implementation aren't shown. Okay, so let's go ahead and just start here. I was like just dragging things down here. We'll have our class called point. Whoa, that's not it. And then we'll close it. Okay, so we open it, close it. I like to open and close it right there. And then we have our instance variables right here. I have my constructor. So let's also end the constructor as well. Okay, we'll have to put something in the constructor here in a second. We'll take this x as x and y come in and assign it to this x and this y. And then the get distance. Okay, let's see what we want it to do. It says get distance method that takes in another point object as an argument and calculates the distance from this object to that one, which would be the square root of this x minus other x squared plus this y minus other y squared, all the square root of. So let me look through this. Math pal. This x minus other dot x, other dot get x. Okay, squared plus math pal this y minus other dot get y. There are associated get x and get y methods whose limitations aren't shown. Good to know. Drag necessary code from left to right. So there should be a get distance method which takes in another point object. Okay, so this and other. I don't know if we ever talked about other. So the fact they're writing this in a question is interesting. We have get x methods, trying to see what the difference between these two is. Math.pal, get x, get y, raise the second power, this y minus other dot get y squared. Interesting. So I'm looking through this. Math dot square root. The math dot pal, okay, that sets up as a power, and we're saying raising to the power of 2. We want it to be the square root of this x minus other dot get x. And then raising that to the second power. Okay, and the other one we're subtracting it and raising it to the power of 2. Let me see what the top one does. I know it's been a while since I've used the math class. Yeah. Okay, so with this 2, let's just see what would happen if I like dragged in the other one. All right, let's see if it gives like a reason. What's going on? No, not reset. Oh, goodness. Well, I just did it. Okay. Did I put these back next to each other now? Why all of a sudden are they next to each other? I like it when they're next to each other. Let's see if it gives us a reason why. I'll do this quick, right? Instance variables. This, and we'll close the constructor, and we'll return this one. We didn't put this one the first time. Let's check it. Okay, it says it doesn't give us a reason why. Okay, but using the math class like we did before. Okay, math.square root, and then from here math.pow. We use that instead of raising it to the second power there. You probably should have had the reason why, because you're finding the square root of, let's see, because that closes this there. It might be best to contain that, right? The square root, raise to the second power plus, that's probably the reason why right there. Okay, we have two more. Okay, this one, so the following program should define an account class. All right, let's do that. Here's my open. Here's my end of class here. My instance variables are right here. Okay. By pulling out my instance variables, it looks like there's already an account constructor that brings in the balance and owner. So I'm going to go ahead and say this balance and assign the balance being brought in here to the instance variable. Then if we close the constructor, once again, I haven't even read what I'm supposed to do, but I'm just putting pieces together here. Then the withdrawal, let's see what, well, drag this down here. If amount is greater than this balance, then take out whatever the amount is. Okay. And then else, keep the balance at 0. Don't let them go under 0. All right, let's see. First, let me read if that's what it even wanted here. It says to decrease the balance should be withdrawal. Use a withdrawal method. However, if the balance would be a negative number, it should just be set to 0. Okay. So my account class, instance variables, my constructor brings in 2 parameters. Balance is assigned to instance variable balance. Same as owner assigned here. And my constructor, then I have a withdrawal method. It's void because nothing is actually returned in all this. It's just, making that behind the scenes withdrawal. It says the amount, if it's greater than the balance. If the amount that's being withdrawn is greater than the balance, then set the balance to 0. Else, subtract from the balance. Okay, let's run it. Perfect. So what it's saying is if the amount is actually greater than whatever the balance is, set to 0. It should be like, hey, if the amount is greater than the balance, then don't let anything happen. Don't assign it to 0, right? All right, last one. Have a character class. Let's drag that down here. We're going to close it then. Have my instance variables. Instance variables, constructor, and getter setters are not shown. Interesting. Okay. So the following program should define a character class. Each character instance should have an integer, health points, and write this down. Int health points, and a string name. There's a constructor, and there's a get HP method, and there's a set HP method, and a get name. All right. Finally, there needs to be a fight, and the fight is going to take in from character, and it's going to be other method that lets a character fight another. If the character's health points are the same or more than the other's HP should be set to 0. Okay, so let's just drag this in here. Okay, so my fight. Okay. Let's see here. I'll drag this if down here. And then I'll end my if. And then I'll bring my else down here. And end my else. Okay, so really we got to figure out what we want to put in if and else. So if this get HP is greater than the other get HP, if the character are the same or more than the other's HP, others' HP should be set to 0. Okay, so let's see. The current character's HP should be set to the difference. And the program should print the character's name wins. If others' HP is greater, the current character's HP should be set to 0. Others' HP should be set to the difference. And the program should print other name wins. Okay, so whoever has the higher HP. So if this is greater than or equal to the others, then this guy should win. It's not properly indented, but doesn't need to be. And then else. So let me just walk through this here. So I have a class called character. It's not showing the instance variables, but we have health points, we have name, and then we have the constructor, which gets in all this information. We have a get HP method, a set HP method, and a get name method. And then there's this fight method here. It's void, doesn't return anything. We're passing in the other character. Okay. And from that, it says if this HP is greater than the other character's HP, we want to set this one to whatever the other one was, subtracting it. We also want to set the others to 0, and we want to say we win. Okay, this guy wins. Else, we want to do the opposite, the other guy. Okay, and the other guy would win if he had more HP. 11 out of 11 activities on this page completed. Well done. Been at this for 45 minutes now. Might take a break and then get back to this. But this was 512 mixed up code practice.